already, but it doesn't matter. I haven't really talked so much content. So yeah, when you are learning Java or whatever, some of the concept, you definitely see some of the UML diagrams. And then UML has been changed so much. Back in 2000, this was probably one of the most popular topic in the whole industry, right? And but now people don't even talk about it in the industry, right? It's been the reason is at that time everybody started programming object-oriented programming languages, and then the UML diagram fits the whole object-oriented feature so well. So that's why a lot of people are doing this one. And there is a conference called UPSLA, right? And now the name has been changed into Splash. Okay, you can Google it. It stands for like Object-Oriented Programming Language System or something like that. And it was a very, very popular conference every year. And there was thousands of people going there. These are the things I heard. Okay, I wasn't in the conference in 2000, but I heard that there's thousands of people going there. And most of them are actually from industry. They pay a lot of money to go there, attend tutorial to learn UML. But today, I would say UML is almost dead. Okay, the reason I still want to talk about this one is because we still use a lot of UML to describe the design and to give you a clear picture about what the structure of the class should look like. It's a very easy way to present it. But other than that, not really much useful. So I only have this one lecture. Obviously, we're not going to finish that today, but it's just one lecture I want to share the most important thing you need to know about UML. UML has a lot of things going on. You can buy a book to look at all the different diagrams, but in reality, I think you only need 3 kind of diagrams most often. So I will cover those very quickly. Okay, you don't really need to know or use it too much, but be able to understand and read some of the diagrams. That's the requirements. All right, so what is UML? It is a graphical language, mostly you can think about that as a kind of specification. But it highlights some of the facts that they try to visualize their software design and specify the functions, definitions. It helps you to construct stuff. I'll talk more about that. And also you can obviously use that one for documentation purpose. Okay. So specific for visualization. All right, so this is very easy to understand. And if you look at this kind of a class diagrams, it gives you all the structures, the organizations and everything. And so that you can see, oh, how many classes and components we have in this system. What's the relationship, right? Otherwise, if I give you this many source code classes, then it's so overwhelming, you can't really decide anything, right? So visualization is really important. And visualization is also important to software design. I'll talk a little bit more, but because sometimes it's very difficult to visualize software, but this one does give you some kind of a level of visualization, all right? Now, specifying is mostly talking about specify the feature, the functionality, requirement of the system, all right? High level, what do you want to do with the system, all of those. Constructing means that you can actually generate some of the code from the UML diagrams automatically. So build some kind of a software directly. So there are a lot of tools that helps to do this one, that they build all the UML diagram first, some other diagram, and you can generate part of the code from the diagrams so that you don't have to manually write them again. A very easy example would be if you write a class diagram, you put all the attributes and associations, then they can generate the code directly from those class diagrams. So very straightforward. And that's also the purpose of UML, especially in the later stage of UML. A lot of the tools are developed to do that kind of thing. And documentation, basically that's the whole purpose of the UML. We try to give you a better documentation for the design, for the system, for the features and everything. All right. So in other words, it just gave you this whole like a blueprints, a big picture design for the software system. It tried to capture both for the concept things like features, functionality, but also very concrete stuff like design, database schema, the relationship, associations, all of those, right? So this one is important for software because software in nature, they're not easy to be documented or visualized. That's why making software in many cases is much more challenging than making some other project. Even though you don't need a lot of hard work or physical stuff, you just need a computer sit there, but it doesn't really mean that project is easier to make compared with building a house or doing some other projects, right? Let's say the construction as the example. I actually have no experience on the construction until I was working on this AI project. We did a lot of project with some of the construction companies. I actually worked with some of the big ones. There's one in Texas, and there's another one, a very famous construction company, Turner. Okay, now remember the name. Turner is one of the biggest one in the country, and they build a lot of the big stuff like the 49, the Levi Stadium in Bay Area. And that's the company they built it. So we did a lot of project, and then that's when I learned that in the construction company these days, obviously they have a lot of design, right? So this kind of a floor plan like here probably are the ones you think they still have those. Every construction site you can find there is a little room. You go there, you can find tons of pieces of large paper that has this kind of a floor plans, and the workers actually need to go back and check this one very, very often. Okay, so they use this frequently, at least those managers. But these are really old-fashioned. All right, so these days they all use something called a BIM model. Not sure how many of you heard about that. I forgot what it stands for, but BIM. Okay, BIM model. So basically, this is a 3D model for the whole building. And then the cool thing about this model is it model different perspectives. A model, for example, how the structures, I forgot how this are talking about, what's the term, structures, right? They model the pipes, they model the electricities, they model every like a single aspect. So you can choose which one to show, which one to hide, and very easily. So what I want to show you this one is, when you're trying to build a house or build a building, if you have this kind of a model, all right, it's going to help you so much. Just like I think another good example would be like building a Lego a piece, right? When they gave you this instruction, when they gave you a visualized, a built product, then it's so easy for you to follow it, right? So that's why having this kind of blueprint is really important. However, for software, you pretty much can read. It's impossible to have this kind of model. You cannot see what the software looks like. You cannot see it internally. You cannot see how the algorithm should work. You cannot really model all the connections and relationship. So UML is trying to give you something like this, but I don't think UML can do that much, at this level, just because of the complexity of the software itself. All right. So that's why we also want to think about the ways to really do something like that, to be able to use this model, help us to communicate some of our design, to visualize it, understand it, so that will lower the risk. Because we don't want to have different developers to have a misunderstanding about the feature, about design. That will be the thing that we don't want to see. All right. So that's why we need the UML. And this is the history about the UML. It started in the early 90s when the object-oriented program started getting popular. But in the beginning, there wasn't very much standard. Different groups are making this one using different kind of formats. And then eventually, some of the popular ones, they start to merge all together. And eventually it's called UML. All right. And then one of the most important person is this Grandy Butch, this guy here. Okay. And he was, I think, a very like a principal high-level engineer in IBM. And if you Google his name, you can find a lot of books about object-oriented design, UML diagram about him. Okay, so I met him back in 2009 in one of the modeling conferences, and he gave a talk there. It's a very cool guy that he gave a really good speech, very experienced in terms of software design and everything. There was a little video, I think I have a link somewhere here. Okay, so. About this one here.
There's another intelligent man in
you
the
guys
front row
hear
who bought
this?
his Macintosh too, although yours is pimped out more than mine is with all the decals. Want to raise it up for the camera and get a shot? And there you go. Thanks for having me. The reason I'm here in the area has been working with Dirk and others on an effort that you'll hear a little bit about on building a handbook of software architecture. My two passions, since I'm no longer dead, a year ago I went under surgery. It was open heart surgery to cure an aneurysm. So I was like dead for a while, which was not a cool place to be. So I'm back, which is really nice. A bit of a humbling experience in that process when I was diagnosed with an aneurysm. Every male in my lineage has this defect in their upper aorta. So I went through a CT scan and I was laying there. It was a machine by Siemens. And I looked at it and said, damn, I know the guys who wrote the software for this machine. So, and they used the UML. So, well, I felt good, but it was kind of.
Right. So yeah. So he did mention about Siemens. I also know that company very well. So they build a lot of large this healthcare devices. Siemens actually have a lot of software engineers, as much more than you thought. They one point they might have the most number of software engineers in the whole company. It's a giant company. But yeah, they do use a lot of design. And then this guy was really popular in object-oriented work, but I don't think he's really active that much. I think mainly because of health issues. All right, but definitely a top guy in this field. All right. So for the UML, there are 13 different diagrams. I don't know what's this latest version, but it used to be 13. There's 3 categories. There are structure diagrams, talk more about the structure like class and object. There are behavioral, mostly about the sequence, not sequence, like the functions, the function you want to specify for each component, and also how different things are interact with each other. Right? So these different categories. And obviously, you don't really need to know all of those. I just want to focus on these 3 from 3 different categories. The most important one, obviously, is the class diagram. That's the one you also use very often. And then you also need to use this very simple diagram called use case diagram. I've seen people use this one to talk about the system feature very often, very convenient. And there's also a sequence diagram. This is a very complicated diagram, but then you will have some situation where you will see people use this one. Other than these 3, I really don't see others being used a lot, okay? Especially like a lot of this stuff, rarely people still using that, right? So, class diagram here is the very first one. I'll just go through some of these things very quick, and it's really not difficult. Basically, you try to specify all the class structure because in object-oriented design, it's all about class. In Java, everything is a class. In C++, you don't have to use class, but in Java, everything you need to have a class. So that's why we want to represent this one with a good structure. And this is how we specify the class. As you already know, you have this kind of box here, type the name of the class, the attributes, some of the methods here, and then you can use some of these visibilities controls on the private or public. I think this means private. For the plus means public, or some other things. You can look at the specification. And so yeah, so class name, attributes, and methods. And these are like very detailed, as I mentioned. Okay, plus means public, and the pound means protected, and minus means private. And this one means the package level. This one means derived is probably for the C++ to use. All right. So, but sometimes you know this kind of a visibility control, but in reality, rarely people actually put those one because we assume that this one you should definitely use private, as I explained to you. That's why you don't have to specify that much detail. But at least these are for attributes, these are for the methods. All right. You can also put some of the default values. So these are too much detail. I don't think you need to know how to use all of this. Somehow it's that slide mess up. And the method, same thing. You have the visibility for the method. You also can do static method by using underscore. And you can list all the parameter types with this kind of a colon structure. You can specify return type. and you can specify the method like this, okay, just to know what's the format, okay? But most of the time, we just need you to be able to read and understand what this class does, what are the methods. And you can put comments by dragging this little box here like this and type some comments. A lot of the tools that allows you to write UML diagram, you can put those things here. All right. And then class also important thing, you have the relationship, right? You can do two different kind of relation. One is generalization, one is association. So generalization is more about the inheritance, where this one is more about the composition. Remember last time we talked about composition, you use a reference, okay? So generalization is more commonly used in object-oriented design because it's all about object OOP. You have the inheritance feature, you reuse. So you basically have this up pointing arrow to specify your parent class, and then this is the subclass, and this is another subclass after that level. All right, and then this is how you specify whether it's a class or abstract class or interface. It looks like interface, you use this kind of a double brackets. If it's abstract class, it looks like you do maybe the italic, maybe. So, but again, these are too much detail, and you even specify if it's interface, then you do dash line. But in reality, we don't write this one because if you know this interface, well, of course you will have to implement it, right? So, but you know, if you're talking about the full 100% follow the specification, that's the right way to do it. Okay, how you specify different kind of inheritance, whether it's implement or extends. So as you can see, this UML diagram, it really try to fit Java, all right? Because at that time, Java is obviously the most popular object-oriented programming language. So that's why a lot of features in Java are supported here. Association is more about like a relationship by referencing, okay, or we call it composition. Like so when this class can contain multiple class B, and you can specify this kind of connection. As you can see, they're not in an inheritance relationship. They're just saying this one could have multiple class B. And you can specify how many or more, all of this, and you can specify relation name that contains, all right? And you can do one-on-one relationship. Every one student only has one ID card. You can do one-to-many. Okay, so you got a list of rectangle, can has many rectangles. All right. And these are more specific differentiations about the association, right? So you can say that the car has one engine. This is called aggregation. Our composition means that the book is composed of all the pages, where the car is not composed by an engine. It's just only one part of it. And dependency means that if you are doing this one, you will need to use another one. For example, the lottery ticket, you will need to use a random function. Okay, but they all, as you can see, when you write the code, they all looks like same. Like you create a reference object and then call it. But this one, you just need to know there are different type of association you can do with this different situation. All right, but when you write a diagram, you don't need to differentiate that too much. Okay, whether this is a composition or dependency, that's a lot to specify. Okay, most of the design diagram we show you also don't have this much detail, but at least I want you to know that these are things you can specify with UML. All right. And this is what I mean. Just very simple. Just have an error to say, okay, this one we need to use that one. That's it. That's actually more common. All right. So here are the examples. We'll talk a little bit more about example next time. Okay, but for here, I want to stop here. Definitely take a look at the basic UML class diagram. Okay, maybe you already forgot some of those, but go back to pick it up and learn more about it. All right, next time we'll look at some examples. Sometimes the interview do have questions about the system design where you will need to draw some UML diagrams. All right. Okay, so that's all I want to share today. And next time we'll finish the UML diagram. And after that, we'll talk more about some other principles. All right. Okay, so let me know if you have any kind of questions. I probably won't be able to stay too long today. I have another meeting after this. But again, let me know anything you need. Yeah, I'm putting the slide right now.